OR gate is a circuit that outputs a logic 1 when either of the two inputs is 1. Starting from the most basic logic gate will allow us to incorporate it into the creation of a more complex digital circuit later. This is the truth table that shows the behavior of the OR gate for different combinations of inputs. When two inputs are in the off state, the output will be off. The output will be on when either or both of the two inputs are on. Now let's see how we can create this OR gate with artificial neurons using our platform FEAGI. FEAGI is an open source platform that enables neuroscience principles to be used for robotics. To learn more about FEAGI, please check out the link in the description. You can create the two inputs in the OR gate using the Add New Cortical Area feature. For cortical area type, select Custom. You can give the cortical area whatever name you want. For demonstration purpose, I will name this Input A to match what we have in the truth table. Here you can select the dimension that you want for the cortical area. For simplicity's sake, we will keep all the cortical areas as 1 voxel. Then you can set the location of the neuron by inputting XYZ values. Before setting any parameters in the neuron, I will create the other input neuron and the output neuron following the same steps. Then I'll connect the two input neurons to the output neuron so we can see how changes in the input can impact the output by adding an e-ferrite mapping here. I will select output as the destination cortical area. Then in the mapping definition, I will choose block to block as our rule. By having PSP multiplier as a positive value, the input neuron will have an excitatory effect on the output neuron, meaning that it will activate the output neuron to fire. Now we will change the parameters within each input and output neurons to ensure our OR gate is functioning as what is stated in the truth table. First, the output neuron is not firing when both input neurons are not activated, so row 1 of the truth table checks out. Now let's set the postsynaptic potential of the input neurons and the firing threshold of the output neuron to satisfy the true conditions for the OR gate. Postsynaptic potential is how much of an influence that the input neuron is going to exert on the output neuron. In order to have the output neuron to fire when either of the input neurons is activated, we need to set the firing threshold of the output neuron to be less than the postsynaptic potential of a single input neuron. I will set the firing threshold of the output neuron to be 50, and the postsynaptic potential of the two input neurons to be 100. Now pressing down the Shift key and clicking on the neuron will allow you to manually stimulate the input neuron. So when either of the input neurons is stimulated, the output neuron will be turned on. Of course, when both inputs are stimulated, the output neuron will also be on. Now our OR gate is all set. Let's see how it behaves again. Thank you for watching.